Once you understand this about fuel pressure, understanding a fuel problem with a fuel-injected outboard is going to be way simpler for you. Outside of making sure that you have good clean fuel going to the outboard, checking your fuel pressure is like the first step that you take when diagnosing a problem with a fuel-injected outboard. The issue is the what, why, and how of how the outboard gets this pressure can be confusing, but today you'll understand this completely. We'll need to make some diagrams in order to make this super easy to understand, but the outboard's going to use one of these in order for it to make that pressure. This is a high pressure fuel pump. This one is actually indisposed and in use right now. We're doing some testing, so make sure you subscribe to watch this. But it's also going to use one of these. This is a fuel pressure regulator. But how this works, that's what we need to get to. You see, our fuel pump here is going to make as much pressure as it can based on how much power it's given from the ECM, or however the engine is giving power to this fuel pump. But a lot of this is going to start with our piston here. On a combustion engine, this piston sits in a cylinder. Inside of that cylinder, when this piston comes down, it sucks air into the cylinder and creates a vacuum in our intake manifold. The intake manifold is simply the manifold between here being our throttle body on whatever engine you have, and this tube right here that feeds that into our engine being the cylinder. So this right here is our intake manifold. It's always going to be between our throttle plate and the engine cylinder. And this is where we're going to start using a couple of numbers, but don't get too caught up on the numbers and their meaning. Otherwise, it's just going to get confusing and you won't really understand and retain the information that you're about to learn. Just know that the outside atmospheric pressure of the air that is around you at sea level is 14.7 psi. So there is a pressure of 14.7 psi. When our outboard is sitting there idling, the throttle plate is going to be closed. So when the outboard is sitting at idle, our throttle plate is normally closed. That is the throttle plate that opens up as you advance your throttle. So at wide open throttle, it's completely open, and at idle, it is shut. That means that the piston, as the piston comes down in the cylinder and creates that vacuum and sucks air, it creates a vacuum inside of our intake manifold because of this throttle plate being closed. When the throttle plate is wide open, at wide open throttle, the pressure or the vacuum that is in the intake manifold is basically identical to the outside atmospheric pressure of 14.7 to 1. And that very basic explanation of the throttle plate to the cylinder and your intake manifold, that is a very basic understanding of it, and it is crucially important to know that because of this right here, your fuel pressure regulator, and it is directly linked to that intake manifold. So just to recap, at idle, you're going to have a vacuum in the intake manifold because the piston is sucking air into it on the intake stroke, and the throttle plate is closed, creating that vacuum. At wide open throttle, when the throttle plate is completely open, you're allowing all the air that you can into the intake manifold, making it almost identical to the outside atmospheric pressure of the air that is around you. This will change in different elevations. If you are 10,000 feet above sea level in the mountains, the outside atmospheric pressure of the air around you is going to be different than that of it when you're at sea level, where we get that 14.7 barometric pressure. And this is also very dependent on the type of engine. This is a carbureted engine, so all this information doesn't really matter because it doesn't use a fuel pressure regulator. It has a carburetor. But on other engines like a supercharged engine, it is also going to vary on how this all works because it is supercharged. It's not naturally aspirated, meaning that it's just using natural aspiration of the natural air that is around the engine to operate the engine. Most engines are naturally aspirated, though there are a couple of supercharged engines out there. Mercury Verado, probably the most common one, and then some Nispro tunes that are put onto certain Yamahas will put a supercharger on there, but those are far and few between, so just take this generally as naturally aspirated engines. But now that you know that difference, we're going to go back to that intake manifold because the intake manifold creating that vacuum or the pressure is going to be connected to this. This right here is a little hose that's going to go from here to your intake manifold depending on the engine. They're all different, so where they route this hose, that is going to be dependent, but most of these are going to be inside of your VST, on top of the VST, somewhere around the VST. These are always going to be after your high pressure pump. So here is your high pressure fuel pump. That creates pressure. When it leaves this pump, it will go to this item here, which I'm going to open this thing up and we're going to look at the inside of it and draw a diagram of how this thing functions. So you'll notice on the bottom of our fuel pressure regulator, we have a screen here. So this is going to be after the high pressure pump, and you're going to have fuel basically sitting here that is just here. This right here is going to be a return line, and that will return back to your VST or your FSM or wherever this thing is mounted. So this right here will take fuel in, but it just kind of regulates the pressure because there's a diaphragm inside of here, which, let's open this thing up so you can understand it. And as you can see, this is all that is inside of the pressure regulator. It's very simple. We have the screen, a couple O-rings to make sure fuel stays on which side it's supposed to stay on. You have the intake, which is here with a bunch of holes. All those holes are how the fuel goes in. You have a diaphragm with a ball in the middle of it. So there's your ball. You have a spring and then the other side of it. So all of these play a very specific part. Our spring here, this is going to give us our regulator set point, or as some people will call it, a base value or base pressure. And that spring's regulator set point is easy to figure out. Real quick sponsor here. If you like this kind of content, you can learn tons more in our school community. The links will be in the description and in the first comment down below. Our regulator set point is actually really easy to calculate or figure out. All you need is a pressure gauge. So what you do is you put your pressure gauge onto the engine, you turn the key switch to the on position, and you watch your gauge. At the on position, the fuel pump is going to get power and it's going to create pressure. It's going to create a specific amount of pressure, but you're going to look at that number because remember, you do not have the engine running. It's just key on. So the fuel pressure is going to be built up into that spring's pressure, which is your set point or your base pressure. Your regulator set point is when the key on, engine not running, there's no vacuum on the regulator, so therefore that number, depending on your engine, it might be 48, it might be 51, it might be plus minus 4 psi, it might be 38, you know, depending on whatever engine you have, that regulator has that set point, which is the spring pressure. Key on, you're going to see that on your gauge with just the fuel pump building up as much pressure as it can. That spring, as soon as it hits that pressure, it's going to relieve that fuel, giving you your regulator set point. So our fuel is going to come in to the spring. It's going to come in to our regulator. And it's going to be all up in here. And it's going to come back, and that's just basically what it is. It just sits inside of here, filtered by the screen into here, and it sits on this side of our diaphragm there. Our diaphragm has a ball valve on it. So right here, we've got diaphragm, and then on this side, it's got a ball, and that ball goes up and down. So diaphragm, ball valve. So we've got intake, manifold. So the air comes in, it comes down around here, and same thing, comes down around here to this side, but it stays on this side of the diaphragm. Now what that's going to do is it is going to either put a vacuum or a pressure. So at idle, it is going to be sucking up on it, which is going to make it lower. And then if it, as you get advance the throttle, it's going to create pressure. That pressure on there is going to push it down, which is going to make more pressure. So as this right here goes down, it creates pressure. As it comes up, it lets more fuel out. So as soon as this thing comes up, like you got this ball valve here, as soon as this thing comes up, it allows fuel to go from this side to this side here in the middle. So once you've got no pressure on this, that means there's going to be less fuel going out of here, creating less fuel pressure. The tighter this gets, when this goes down, it creates less. And think about a garden hose. When you put your finger on the garden hose, you create more pressure. Same thing here. When this goes down, it lets less fuel flow by our ball valve, and with less fuel flowing through the ball valve, getting back to here, which is a return line, I'm gonna put intake fuel, but let me change this up. Out of the middle of this, we have return fuel. And that returns to the VST or the FSM. So when we have a vacuum on this, it takes the ball away, which allows more fuel to flow through the regulator and back to the return VST FSM. When we have wide open throttle, we have more pressure on the spring pushing it down. When it pushes down, it has less fuel returning to the VST, which increases our fuel pressure. Now, this is the most common type of pressure regulator for fuel. Again, it all has to go with this diaphragm and that ball valve, and then the inlet ports, as well as the outlet port right here in the middle. Now, this is basically a, I guess you could call it a dead-headed type of system, because the fuel goes to the injectors on the fuel rail, where there are some of these systems where the fuel will go to the fuel rail, but it will also have a return path from the fuel rail back to your VST. And that is like a recirculating type of pressure regulator, where this regulator is allowing that fuel to return from your fuel line. Whereas the ones that are in your VST or are on top of the VST, those go to your fuel rail, but there's no return path to the FSM or the VST from your fuel rail. If there's no return path from the fuel rail, that is considered a dead-headed system, fuel system. But again, that goes way far and above and beyond how these pressure regulators work. But now that you understand how these pressure regulators work, you know that if you have a cut in the fuel line or your intake air manifold, like if your pressure isn't right on the intake, your throttle plate is stuck closed, or you have a leaky gasket on the intake manifold, or you have any kind of issue like that, it's gonna mess with your pressure regulator. Or if, let's say, you get a dirt dauber in the intake, or that line gets pinched somehow, now all of a sudden you do not have a reference from the intake to your pressure regulator, which is going to throw off your fuel pressure. So you know these pressure regulators are pretty easy to diagnose, because you just turn the key on, check your set point. Once you know your set point, start the engine and see what that fuel pressure does. If the fuel pressure doesn't go down because you have a vacuum coming from the intake manifold onto your fuel pressure regulator, then you know there's a clog with that line, or it's not getting the vacuum from the intake manifold to your pressure regulator. Knowing that the inside of the pressure regulator are basically these two items here, usually they don't fail unless they get rusty and broken in that aspect. So if you do not have fuel pressure, before you go diagnosing and saying that one of these regulators are bad, you should clean the VST, make sure that the screen on the bottom of the fuel pump isn't bad, make sure you have good power going to the fuel pump to create enough pressure, because these normally do not fail unless they get super old and super rusty and you use ethanol fuel that eats up this diaphragm. They're a pretty bulletproof component. But now that you understand how they work, you should understand all that a lot better.